So I'm Carl Simpson. Been a postdoc for a year in the Paleobiology Department studying bryozoans under the Abbott Postdoctoral Fellowship. So I'll talk a little bit about bryozoans today, but the bigger context is really humans. And so as humans, we're very intimately familiar with social living, right? We've evolved the capacity for complex economies and politics that just boggle the mind when you think of how they compare to other animals. But despite that, even though our bodies vary a little bit, they're remarkably similar to each other. Other colonial and social animals like these ants and termites illustrate this point, right? So all their different body types are very specialist tasks. Some of them go out and feed, some of them are defensive, some of them just sit back and make babies all day long. It's not a bad life, but none of them can do any of those, the whole thing that the colony needs to do by themselves. And so their teamwork is critical for the functioning of their overall society, much like it is in humans. Now, in the colonial marine organisms like this siphonophore, this integration among the colony members is taken to crazy extremes. Their tissues connect to the individual animals, like each little shiny blub in there is an animal. Their tissues are so integrated that it's hard to tell where one begins and one ends. So the whole colony itself tends to seem like an organism, even though it's a collection of organisms. We don't understand how this works in general. Part of the problem is that most of these transitions have happened far in the past with soft, squishy organisms that don't have a good fossil record. But corals are an example that do have a fossil record, but their integration is fairly limited and they're monomorphic over the whole history of their existence. The bryozoans are skeletonized, and there's two examples here. One is monomorphic, much more like a coral, and the other one is a small snapshot into a complex coral that's more like that siphonophore in its integration and division of labor. And they rival the siphonophores themselves for the complex interactions between their members. Now, our theories tell us that these transitions are difficult because the selfishness of the constituents of a colony needs to be quenched, and turned off if these colonies are going to evolve in the first place. But despite that theoretical difficulty, it turns out that this happens, under my estimate, at least 250 times over the history of life, which is quite crazy, and it happens from bees to buffalo. All these very independent types of organisms undergo these transitions independently, and there's enough similarities that there seems to be a hint of parallelism in the evolutionary responses there. One of these critical parallels is that in complex colonies, there's always some sterile members that, though they may be able to propagate themselves, they contribute nothing to the propagation of the colonies as a whole. What that means is that if there's fewer queens in a colony, there's more workers. And that's one of these empirical things that you can't quite see when you look at one specific species. You have to look at a large collection of species, and this is where the bryozoans come in. It's a phylum that's 100% colonial. They have an excellent fossil record, and so you can actually track how they acquire these polymorphic zooids, these animals of different shapes. The animals themselves live in little skeletal shoeboxes, and those dark ovals are their apertures. There's a little lid that they can pop up, and they stick out their tentacles to feed. The little teardrop-shaped things next to those ovals are separate animals that live on the surface of their host-like compatriots in the colony, like Quado does in Total Recall, if you're familiar. Which, good, at least everybody is. Not the new one. Now, it's even more crazy, right? The circular globular structures that are on the center are animals that are specialized for housing larvae and brooding larvae. In this species, they tend to occur in the center of the colony. And as the colony expands out clonally, there's a wave front of sexual activity that expands out also. And so they're doing clonal growth and sexual reproduction. Clonal, remember, is expanding the colony, and sex is making new colonies. Okay, so let's zoom in a little bit here. We can see the three polymorphs of that species. That little teardrop-shaped guy, it's modified its hatch to be pointy. It's given up its feeding tentacles, and it depends completely for nourishment on the feeding zooids that it's attached to. And the large globular structures also have a little hole to them. They're modified spines in some way, which may themselves have been long separate individuals. Now here's a dramatic one. The differences in the polymorphs here are quite stark. There's a large globular larval chamber there, which is covered in these animals that are modified to be pikes. And what you see, the difference between these two, if I make a little animation, is that those that are simple with very few different types of polymorphs tend to have lots of these sexually active members. And those that have a crazy number of polymorphs, like this one, tend to have very sparse, rare, though sometimes quite large, reproductive members. Now what this does, oh, and you can see even more. Here's an even crazier polymorph in the same colony. One of those feeding zooids is modified to be this large duckbill shape. Okay, so the context is that this frequency of reproductive capacity for the ability to found new colonies in an organism is a knob that's tuned that allows the evolution of this complexity to happen without turning off the fitnesses and selfishness of the members. Thanks, everybody. I just squeaked by. Okay.
You may have a question.
Okay, so in spiders, when they evolve social behavior, they become homozygous. Because they're homozygous, the social lineages always go extinct because they can't survive macroevolutionary challenges. So in the fossil history of bryozoans, is sociality emerging from a network of social ancestors or asocial?
It's hard to tell. We don't really know where they fit in the overall tree. They seem to, they're colonial all the way back. But there is a hint that for different social groups in the sea, that those that are more social and colonial do have a higher tendency to go extinct. So that may be a kind of a common feature.